Now A12, okay, this is fixed, and ignore this row in the first element and move to this one. This is the determinant of this one. 3 minus 1 and 1, 4. And plus minus 1 to the power what? 2 plus 2. 2 plus 2 times A2 by 2. This element I mean 1 times the determinant of what? Determinant of what? Let me highlight it. This is fixed, yeah, and this is fixed because in this element the row of this element is fixed and the column, the main column that we selected it is also fixed. Therefore we can use what? Therefore we use 1 1 1 1, and this is 2 and 4. 2 and 4, yeah. Plus minus 1 to the power what? Oops. To the power 3 plus 2. 3 plus 2 times A3 by 3 2 means this two element, yeah, A22, A32, yeah, times the determinant of. Okay, let me highlight it. This is always fixed, and we fix the third row. Then what's remaining? This is the remaining. If this is remaining, 1 3, 1 3, and 2 minus 1, like this one. Now we can solve the determinant. We can find the determinant of A. Substitute minus 1 to the power what means? This is power 3 times A12 means the 0 times the determinant of 3 minus 1 1 4. This is 0 means this is ignore. 0 plus minus 1 to the power what? 4 times A22 means 1 times the determinant of what? A1 2 1 4 plus, let me use this, plus minus 1 3 plus 5 5, 3 plus 2 5 times the element 3 2 means 2 times the determinant, this one, this determinant. Now we can find determinant of A is equal to what? 0 plus what? Minus 1 to the power 4 what? 1. 1 times 1, 1. Determinant of this one, 1 times 4 minus 2. 4 minus 2. 4 minus 2 plus minus 1 to the power 5 minus 1. Minus 1. Minus 1 times the element 2. Element 2. This element 3 2 means 2 times the determinant. Determinant of this one, 1 times minus 1 minus 1 minus 5 minus 6 minus 6, and this is 1 equal to 0 plus 2 minus 1 times plus 12, which is equal to the 40. This 1 minus, okay, this 1 minus 1, four minus 2 is 2 plus, this is 1, let me check it, okay, this is 1, minus 1 to the power, okay, times 2, and determinant minus 1 Okay, this one. Okay. To the power, okay, 5, is it? Minus 1 to the power 5 times 3, which is 2, times the determinant minus 1, minus 1, minus 6, plus 6. Okay, this is plus 12 plus 2, 14. This is the determinant, 14. Determinant of A is equal to the 14. Now, let me explain the Cramer's rule. Now, we use another color for the Cramer's rule. Okay. Cramer rule. Okay. Given n by n mean square matrix system of a linear equations. Okay. Let Cx equal to A. I'll explain Cx and A. Yeah. Be the matrix form of the given system. C means the coefficient. This one, C is equal to what? The coefficient is like x1, x2, x3, and xn. Yeah, like this one. This is elements. N by n. Okay. And x, like this one. Okay. Let me see x equal to a. C is, as I said, coefficient. Okay. Like this one. C n by n also should be times x1 xn. Okay, like x1 x2 x3 and so on, equal to the solution a1 a2 an, like this one. Yeah, the system has a unique solution. If and only if, remember this one, if and only if, I will explain it. Determinant of C, this C matrix. As I said, C is this matrix. This is matrix, yeah. Okay, determinant of C is what? Is not equal to the 0. This is a statement means the system has a unique solution, one solution only. It means one solution only. A unique solution if and only if determinant of C not equal to the 0. And I will explain another statement. System has a unique solution if and only if determinant of C not equal 0. If the determinant of C not equal to 0, then the system has a unique solution. Now let me explain the Cramer's rule. Cramer's rule. Okay, we use the Cramer rule to find x1, this x1, x2 and x3 and so on, xn. Yeah. To find the x1 is equal to what? To the determinant of a1, a2, an, and x2, it still remains the element, and xn still, over the determinant of C, and this is the same for x2 equal to the determinant of x1 still the same, a to the xn, the elements. Then we substitute instead of x2 this element, substitute this one, a1 an, and x3 is still the same, xn is still the same, yeah, over determinant of c. Let me give you an example about that. Okay, let me use another example. Okay, use this example. Okay, use the Cramer's rule to solve this system of linear equations. To solve the following system of linear equations. Okay, as follows. This system is 2x1 plus 7x2 equal to 13 minus 10 x1 plus 3x2 equal to minus 4. Solution. We want to use the Cramer to solve the following system of linear equation. Okay, let me use another color. Okay, first of all we write this system in this form. We write the system in this form: c times x1 xn equal to c x equal to a. Oops. Okay, the following system, let me repeat the following system. This 2x1 plus 7x2 equal to 13, and this one minus 10x1 plus 3x2 equal to minus 4. Let me write it. Solution. Use Cramer's rule. Okay, first we write the system as this form. The matrix form, cx equal to a, like this one. First, the coefficient 2, and this coefficient 7, and this coefficient minus 10, this coefficient 3, and this is x1 and x2, because we have only x1 and x2, no x3, which is equal to what? The solution 13 minus 4. Amazing. Now we want to find the determinant of c first. Determinant of c, this is c, this is x, and this is a. Cx equal to a, yeah. Determinant of c, 2 times 3 minus 7 times minus 10, yeah. 2 times 3 minus 7 times minus 10, which is equal to 6 minus 70, which is equal to the 76. Not equal to 0, which is not equal to 0. Then we can use Cramer. Determinant of c not equal to the 0, then use the Cramer's. If equal to 0, we cannot use the Cramer's rule, yeah. Then now we want to find x1. x1 equal to what? Determinant, as I said, determinant of, for x1 we have this x1, this x1, this x2. We substitute this one by the solution. 13 minus 4, and this is still the remaining 7 and 3 over determinant of c, which is 76. The determinant this one, 13 times 3 minus this one, this one, okay, 13 13 times 3 minus 4 times 7 over the 76, and you can find the solution. And x2 equal to determinant of what? x1 is still the same, 2 and minus 10, 2 and minus 10, and this is will be changed with this one, substitute 13 over the solution, 13, because we want to find what? x2. This because we want to find x1, we substitute by x1 column, x2 column substitute by 13 and minus 4 over determinant of c, and you can find determinant 2 times minus 4 minus 13 times minus 10 over 76, and you can find the solution, and so on. You can use the Cramer to find the solution for x1 and x2. Okay, now let me give you a homework 5.2 as a practice for your own. First of all, solve the second question in the problem set 5. Then please check your answer with the post solution for the problem set 5 under the week 5 section in the course website at Udemy. If you have any question concerning any part of the problem set, please do not hesitate to ask me a question in the forum, or send me an email to my personal email, or leave a message in my website in the first web page. Good luck.